everyone, welcome to your tutor ZM, and in this video we're going to be looking at three variable simultaneous equations. So when we look at the simultaneous equation that we have here, it might be intimidating to the eye, but it's very simple. The only key is just to look for a letter which can be easily eliminated. In this case, C can be easily eliminated because we've got -1, -2, and +1. So I'm going to go ahead and name the equations and give the equations numbers. So this here will be my equation 1, this will be my equation 2, and then this will be my equation 3. So notice that if I get equation 1 and equation 3, if I add them, the C's will subtract itself out. So what do I mean? Let me go ahead and put my equation 2, my equation 1 and 3 together. Yeah, so I think I can do this at the corner. So this will become 2a plus b minus c is equal to -1. And then now let me go for my equation 5. 5a plus 2b plus c is equal to 5. So notice if I add the c's here, I would get a 0. So what I can do is that I can simply put an underlining line and then say 2a plus 5a, which is 7a, yeah. So here I'm going to have a 7a plus b plus 2b, which is obviously 3b. And then when I say minus c plus c, obviously I'm going to get a 0, but I'm not going to indicate that 0 because it has no value. So I'm going to put this equal to, and then I'm going to go on to this part and say -1 plus 5, which is obviously 4. Yeah, so notice that I have formed an equation. Now for the sake of distinction, I'm going to name this equation, let me just name it equation 1 because it's my newest equation, and I'm going to name it equation 1 in blue. So can we do the same with c and eliminate c again? Of course we can. I can get my equation 2 and my equation 3 and do the same, but of course I will have to manipulate it a little bit for me to get a c to equate to 0. So I can have my equation 2 here, a plus 3b minus 2c is equal to -6. And then here I can have my 5a plus 2b plus c is equal to 5. Yeah, so I'm sure if you're a step ahead of me and that you've already tried, once you say -2c plus c, it's always going to give you -c, and then we do not want a -c, we want the c to completely go to 0. So what can I do to make my c go to 0? I can simply multiply the whole equation 3 by a 2. And will I have broken any mathematical rule? No, because I'll be multiplying my c with everything, including the 5, this ends. So once you're multiplying, it's very important to show the brackets of multiplication, as I have done, and then my 2 out here to show that I'm multiplying everything that is inside. So I can go ahead, draw my line right here, and then I can bring back everything down with my top equation. I can still bring it back because now it still has been unchanged, which is equation 2. Equation 2 remains unchanged. Equation 2 remains unchanged. So let me just write my equation 2 is equal to -6. And then now we're at this point, so 2 times 5a, which will be basically 10a, plus 2 times 2b, which will become 4b, and then 2 times c, which will give us 2c. And then one mistake that pupils make is they get too excited and then they'll just bring the 5 here down. But we're multiplying everything, including the 5, by 2. So 2 times 5 is 10. I also used to make that mistake a lot. Okay, and now that we are here, let me use a darker shade of gray. Now, at this point, we can add our equations, because notice that once we add our c's, they'll go to 0. So a plus 10a will just be, we'll have 11a's plus 3b plus 4b, that will become a 7b. And then negative 2c plus 2c, that will be a 0. We do not indicate a 0. And then negative 6 plus 10 is obviously positive 4. So notice that I have come up with another equation. So I'm just going to call this equation 2. And then at this point, hold up, we've got two equations that we can solve simultaneously from the rules that we know. So I am just going to get a shape, a dividing line, to just show that there's a certain demarcation right here. And let me just put this to red. Wow, yeah, for me to see my equations. So I can have my equation 1 and my equation 2, and I can solve them simultaneously. So I can bring my equation 1, which is here, and then let's say 7a plus 3b is equals to 4. And then 11, oh wow, that's an ugly looking one. 11a plus 7b is equal to 4. So once we reach this point, we can use any normal rule in simultaneous equations. We can either use substitution or we can use elimination. But since we started with elimination, so why don't we go ahead and eliminate all the way? So now this is another trick on simultaneous equations. Once you have got, I like eliminating the term which is usually this side and like the term which is this side. So if I wanted to eliminate the term which is this side, this is a simple trick. I have a 7 and I have a 3 here. So what I'm simply going to do is that I'm going to bring brackets on both ends of my equations. Even here on top, I'm going to bring brackets. Let me just redo that bracket. And then what we're going to do is that we're going to get the same 3, except the 3 I'll bring it here down, and then I'm going to bring the 7 down there on top. I'm going to bring my 7 here on top. Then what it is that I have to make one negative and the other one positive. So it depends with whichever one you choose, but I love choosing the smaller number, which is 3 in this case. So I'm going to make my 3 negative. And then once I do that, I'm simply going to multiply 7 times 7, which is 49. So I'm going to have 49a plus 7 times 3, which is 21. So I'm going to have plus 21b. 7 times 4, which is 28. 28. And then now let me come a little bit down. And then now I'm going to do the same with my negative 3. So negative 3 times 11 will have negative 33a. Oh, I was too rush. I was in a rush. Then we'll have negative 3 multiplying our positive 7, which will give us a negative 21b. Negative 21b. Negative 3 times 4, which will be obviously a negative 12. And then at this juncture that we have reached, notice that once we add the b's, they can easily go to 0. So I'm simply going to add. So once I add 49 minus 33, I'm going to get a 16a. 16a is going to be equivalent to, because this will obviously go to 0 and we do not indicate the 0 as I have mentioned. And then once we say 23 minus 12, it's going to give us 16. And then we can divide both sides by 16. Dividing both sides by 16 to find that our a will be equivalent to 1. So now that we know that our a is equivalent to 1, we can go ahead and pick one of the original equations to find our solution of b. Not these multiplied by factors, but one of the original equations. So I'm going to go ahead and pick this same equation, which is right here. I'm just going to bring it here, and since I know that my value of a is 1, I'm simply going to replace here with 1 and see what my value of b will be. So I'm going to have 11 and see what my value of b will be. That was unplanned for. Okay, yeah, so we're going to have 11a plus 7b being equal to 4. So where I have a, I'm just going to replace with 1. And it's very important if you're in an exam or if you're in a test to show each and every step. That's why I'm being cautious. So this will become 11 plus 7b being equal to 4. Then this will become 7b, the additive inverse of 11, which is negative 11. So it's going to go that side, or as you say, 11 crosses a cosine and changes and becomes negative, which is basically the additive inverse. Yeah, so 4 minus 7, that is 7, and a negative 7 for that matter. So I'm going to divide by 7 and have my value of b as negative 1. So now that you have found your value of a and b, the last thing, which is probably the easiest, is simply going to be finding our value of c. So since we have a value for a and b, we're simply going to get one of the 3 original equations and substitute, plug in a and b and find our value of c. So I'm going to get the first one. I'm going to get the first equation. The first equation, which is, okay, let me just do this. Yeah, the first equation, which is 2a plus b minus c is equal to negative 1. So I'm simply going to replace 2. My a is 1 plus my b is negative 1. My c is negative, oh, my c is negative c actually. Negative 1. So this will come 2 minus 1 minus c is equal to minus 1. So 2 minus 1, that is 1 minus c. So to be 1 minus c is equal to minus 1. So what can I do? I can take my c that side and bring my 1 this side. So I'll have 1. My 1 crosses this side, it comes this side, it becomes positive. So 1 plus 1 is equal to c. And then therefore my c will be equal to 2. So I have found my value for a, b, and c. I have found that my a is 1, my b is negative 1, and my c is 2. Now, how is it that you confirm if your answers are correct or not? So this is the easiest way of confirming. You can confirm your answers by simply getting the same equation one that you had on top. For confirmation, let me use yellow, and then basically plugging in all the answers that you found, and then seeing if it will equate to this term right here, which is -1. So it's going to be 2 multiplying the a which we have found, which is 1, plus our b which we said was -1, and our c which we have just found to be 2, so it will be minus 2. Now let's see what this will equal. In fact, let me do this. What will this equal? So 2 multiplying by 1, that will be obviously 2. Positive times negative is -1, minus positive negative the same, root 2. So this will become 2. -1 minus 2, that is -3. 2 minus 3 is equal to -1. So -1 and -1 that side. Hence we have proved that the answers that we have found are correct. So this was just a simple illustration to explain how we solve for 3 variable simultaneous equation. And I hope you've enjoyed the video, and I'll be seeing you guys in the next one. Thank you very much.